Hi everybody, good morning. I'm doing some rooms that didn't finish in web application pen tester. I'm doing this one, OAuth Vulnerabilities. Yeah, this room I thought to do it a while ago and then I got busy and lazy and things like that. So I think it's a bit long room, but let's see how learn how the OAuth protocol works and master technique to exploit it. Now, for this introduction, OAuth vulnerability emerge as a serious and frequently disregarded risk when we talk about OAuth. We're talking about Authentication 2.0, the commonly used authorization framework. The vulnerability occurs when a hacker takes advantage of weakness in OAuth 2.0, which allow CSRF accesses, data leakage, and exploitation, and other vulnerabilities. Sorry. So in this room learning objective, essential concept of OAuth 2 flow, identify services, exploit, and evolution of OAuth 2.1 to avoid some stuff. Now we have a couple of labs in this room, 1, 2, 3, 4. There's these ones to practice in that. But for now, let's start first introduction. What is it? This task will discuss the key concept of understanding OAuth, especially OAuth 2.0. This concept from foundation for understanding how OAuth 2.0 framework was built as a pentester or secure coder. It is essential to understand this concept. So basically, this is more introduction, and as always, don't try to memorize the things. This you learn them by doing. When you practice, you know something. Resource owner is the person system that controls certain data and can authorize an application to access that data in their behalf. This concept is fundamental. It's centered around our user consent and control. The client, usually a mobile app or server-side application. The authorization server, that's key. A server is responsible for issuing access token to the client. Sorry. Resource server, the server hosting the protected resource, can accept and respond to protected resource request. Authorization grant, guys, you can read more during the labs. The client uses a credential representing a resource and authorization to access their protected resources to obtain an access token. So that's the story about token here. The primary grant type is authorization code, implicit, resource owner, password, credential, client credential. For example, when you first log into the coffee shop app, you are given authorization grant like entering your username and password. The app uses this grant to get an access token. Access token was the whole holy grail that we're looking for, the credential that the client can be used to access protected resource on behalf of resource owner. A refresh token, a redirect URL where you go after getting that token, the scope, or read, write permission, things like that. Scope are mechanism for limiting application access to user account. Then state parameter and option parameter maintain the state between the client. This one is for against the what do they call that one, cross-site request forgery. So you have some kind of random between the app and the server. So which option parameter? Yeah, that's the last one they want you to read. This is the state. What credential can the client use to access protected resource on behalf of resource owner? Yeah, that's a username password. So to be, no, not username password. It's the whole point of this oath is to get a token. So what do we call authorization access token? Yeah, you can get the concept, but by doing lab things, that's why you start practicing these things. For example, now what's this? The types also provide several grant authorization code grant. An authorization code grant is the most common use of our 2.0 flows suited for server-side application PHP, Java, .NET. In this flow, the client redirects the user to authorization server where the user authenticates and grants authorization. The authorization server then redirects the user to the client with authorization code. Sometimes you find in email these things, so how to make it big? It's bigger there. So resource owner application authorization server, resource server, access application authorization request authorization, authorization grant authorization, send authorization code request, code exchange for token, issue access token, and things like that. Implicit grant is primarily designed for mobile and web application when client can't securely store secret. It directly issues the access token to the client without requiring an authorization code exchange. In this flow, the client redirects the user to authorization server and the user authenticate and grant authorization. So yeah, with the lab we'll understand more about this. Resource owner password credential grant. The resource owner password credential grant is used when the client is highly trusted by the resource owner, such as first-party application. The client collects a user credential, direct and exchange them for access token. Client credential grant. Okay, this is another one. So different oath, different one. I'm trying to go to the lab now. What type of grant type often used in server side? Yeah, usually this one is the client credential. Where is it? The simpler one. The client credentials. Now let's go to our lab and then how we're still not in the lab. Okay. How OAuth 2.0 flow begin when a user resource owner interact with the client. The request has to specific resource. The client redirect the user to an authorization server. It's like what sometimes when you go to a website and it tell you log with your Gmail. You click a Gmail, you go to Google, you authentication, come back. That's type of things. So Bob trying to access an account order, redirect to the login screen, login and grant access to resource, return an auth code, send the auth code along with client detail to auth server grant access token, refresh token, use the token from step 6 and request data from the server. Now let's start. Let's clear for this room. This room will have a domain called coffee.try.thm. We have a victim login. We have the attacker login for the application. We have the bistro and, and all of that. So I have them there. Just put them next to you, especially this one, because if you don't log out for different labs, you will not. Sorry, you need to log out. So let me do. I'm doing certain things the way I'm setting this lab for easy understanding. Let me get this IP. This is my attack box. So you have an attack box. I'm also testing it in the attack box. So let's do this so can everybody can clear what we're doing. Vim etc. You don't need to do this only in the attack box because the IP is not there configured yet. So this is the attack box. So we need the coffee.try.thm, and then we have a coffee and you have the bistro. So now this is the attack box. Now in the other one, this one, it doesn't, you don't need to do that, but just put this one always there so you know it. Now coffee admins, this one is this one, the authenticator. That's the main one. Why you can't go to the coffee, and then we have the bistro. You see, this is where we are. Like for example, now you're going to so So this is the main machine for for this lab. This is my attack box. We'll use different things. We'll show you later on what I mean, why I'm using it. uh, so now we know that's exactly you can see. I'm going to an application called Bistro THM. I'm trying to log in. So usually you click that login. You take you to the coffee, which is mean this one, the coffee one. This is like, think about it like a Gmail, like Google account. Now they already gave us. We can use victim 123. So for example, I can put victim and victim 123, and and that's the scope. So the app is asking read and write permission. You do authorize, you come back, and you are in Bistro, and I'm logging, and that's my profile. Now in this room, of course, they will tell you all these things, what it gets sent and all of that. And now let's do these things where we can see these things now, all these little things. Now let's log out. We have an app to inspect. Let's go to, for example, to the network. Now if I press login, you can see something happen here. Let's collect this data so we can know what we're doing. Let's call it vulnerabilities or report. So for example, you can see we have this. After copy URL, after you click the login, you see what gets sent. This, it go to the coffee, but with this old strange number. Okay, that's cool. If I click now authorize, this is a post request. We don't think we'll pick up the post, but let's see. Now something happened. Let's see what we got here. This is the coffee one. This is the bistro, the callback, copy value. So the first one is called the authenticator, the coffee.TryHackMe. After we authorize, there is a callback. You can see the callback to our main website, the bistro, and it gives the code, authorization code. And yeah, and then we are in the profile, which is this one. Now we don't have to meet all the information, but what we can see here, you can see that we have the client ID, so which is this one. We have a resource type, it's a code. We have a redirect, which means go back to the callback in the bistro app, and when it called back, it gave the code. Now we got some information from Firefox network. Now let's go fancy a little bit. Remember we did this, so we can go to the same. We're not logging out. This is our app. Let's log out so we don't mess up our setup. Let's go to Firefox here. Now we know I'm doing the attack box now. Attack box, why I need it? Because in attack box I can have some tools play with. I have Wireshark, for example. So the idea now, we want to see these values. All the we've been async we didn't see the grant type. We've seen the code, the redirect. We've got the client ID, client secret. We didn't get client secret, I think. What we got? We got the client ID. We got response type with the redirect, and we got the code. That's it. Okay. Now let's see what we can do with Firefox. And remember, if you are in the attack box IP address, sorry, like in this one, we have the ENS5, so I want him to listen to this one, the ENS5. Let it before, let's stop. I don't want it now. So now let's, so everybody can see. Layout. Okay, I put the font. Apply. Okay, so now I have this one will select even the post request, so it's not like for that one. I think we now I didn't start it yet, so we can do the same things. We can just start the captcha. No, what? Hold on. Continue without saving. So let's refresh the page. I'm on it. Click login. Victim. Victim 123. Save. Then I press authorize. Then I'm there. So let's go to then let's stop, because everything is done through HTTP. I can filter HTTP, so to remove the noise. Sorry. So now you can see our what we've been doing here. You can see the first one, the get request to that bistro, the first one. And then we went to which one, that the auth demo auth login, and then we got this authorization. Yes, do this follow. Yeah, you can see what the callback. We got the client ID. We have the code. Location. This is the code callback. Then this one. Where is that form? CSRF cookie. There was a CSRF cookie. Username and password. That's the one that we did the password. And then that coffee. You have see account login, next authorization, client, callback, and then what the encryption this. Okay, this one, the one that we sent before. What the hell is this? Let me see. CF middleware token, bistro, client ID, the scope read and write, a challenge and code challenge method, claim and authorize. That's the one that we did a form for this one. Let's go back to our where's the one that we had that oh, that's the profile after you log in. Oh, this is the method get request, and that's why the code, we have that code here, request path. The query is the, we have that code there, and then the post, that's the post I'm looking for that post. Oh, this is the information I was looking for. Okay, we have the scope, read and write, client ID, we have the state, we have response type, we have the code challenge, this empty is not there, allow, authorize, and then we have all the information that we, and CSRF middleware token for this. So with Wireshark we can get most of the information, and if we go to TryHackMe website we can see all what happened here. The grant type, the code, the redirect. Uh, so at the end of the day, the whole point when you log in, after a log uh, you get that code at the end that we found here. So this one. Remember the last URL we got this one. Go back, call back with the code, and then you give you the authorization. So that's the part. And for example here, what token request, the bistro website exchange the authorization code for an access token by requesting authorization server token endpoint through post request. Remember the post request, we talk about it. And then we have this. So remember we found it, we saw it in Wireshark. The challenge, the response, I don't know what that client secret, I don't think there is secret here. This is the post, and then after that you give straight to that using the parameter. The following code will make a token request to the O token endpoint. This is more like a backend with all the information. And then token response, the authorization server to authenticate the bistro website and validate the authorization code. Upon successful validation, the server responds with an access token and optionally a refresh token. Access token that will be used to access Tom detail, token type Bira, and now in one this is the post request state response type code. This is just a token. There's no what information is talking about there. Access token expire in a refresh token optional no. The expiration duration of the second which access token is valid. I didn't see that things. Okay, let me test something quickly. Let's log out to you from there. If we try now again, I want to check the header. Okay, let's see if we can see anything interested. Is a redirect location, set cookie session ID, expire. This is the this is the cookie. Bistro. We have the code. Okay, now let's see what we are. For example, the question: what is the client ID value after initiating the Auth 2.0 workflow? We already got it in different way, including Wireshark and that, so we can see the client ID. It was part of the response, so we can use that one directly. And then what parameter name determine the time validity is expired in? I don't see that one in my response. Where are you, Wireshark? This one a request, that's the client ID, and then redirect and type code. There's no expiration, and the post uh, the state is empty response, there's no expire on them, then it go back to get request parameter only code here, a code and auth callback. It's only the code, I don't see the expire. Any case, yeah, let's go now start practice another lab. Identify the auth services. Identify auth usage in an application. The first indication that an application uses auth is often found in the login process. Look for option allowing user to log in. Of course, usually whenever you see something like that, like I tell you, log in with something, you know the auth, it's there active. This is another room. Detecting implementation. When analyzing network traffic during login process, pay attention to HTTP redirect. Auth implementation will generally redirect the browser to an authorization server URL. This URL often contains specific query parameters such as a response type, client ID, redirect, and scope. Remember, that's what we got here when we've been doing this, where the first redirect, you can see it's calling the authorization server, and we have the client ID and things, so we know there is auth involved in this one. For example, this one, remember we have this one. Identify the auth framework. Once you have confirmed the auth is being used, the next step is to identify a specific framework or library the application employ. This can provide insight into potential vulnerability. Check HTTP header and response, inspect HTTP header and response bodies. For example, now when we did the let's say if I do follow HTTP, you can see the way it auth demo callback. This is, let's say, Python. So, and then auth demo profile. Well, this is the end what we did, but you can just start from the top. Yeah, auth login. So it already tell you. You can guess it here. Source code. If you can access application source code, search application keyword and simply for instance, libraries like Django Auth Toolkit. It use AuthLib, Spring Auth, or Passport in Node.js. Each have unique characteristic and naming convention. Authorization and token endpoint analyze the endpoint used to obtain authorization code. For example, Django Auth Toolkit, you say auth authorize, auth token. Now in our case, what we got last time, not this one. Auth callback authorize is called O here / which is in its Python, so it's high chance it's a Django toolkit for this our case here. So the question, what the name of toolkit that we're using is this one for this room. Now, exploiting auth, stealing auth token. Now, let me remember this lab first. Oh yeah, this love exploiting an oath, stealing a token play a critical role in OAuth 2.0 framework, acting as digital keys that grant access to protected resources. These tokens are issued by authorization server, okay? And we have a redirect URI. Remember that we keep using redirect URI, this one. Um, The redirect URI parameter is specified during the auth flow to direct where authorization server. Usually, if you open an account or something, you define so the server know where to trust, which one to trust. Attacker strategy. If attacker gain control, for example, dev.bistro thm because it's allowed in the second one, they can exploit the outflow by setting redirect URI in the callback. A crafted attack, the attack initiate an outflow and ensure reductory point to their control domain. So if you can have a control, for example, any of the domains in the list of redirect URIs, now you can take that advantage. Now in this lab, remember most of this lab, make sure you always use this. I had a mistake before and it took me time to figure out what's going on. So you always try to log out, force the log out with this link. Even now it's there, but just make sure you force the log out of the machine. Let me also force the log out here. Now we're done with Wireshark. We can use it later on, I think. Let's force the log out. For this exercise, we assume that attacker has compromised the domain, so we have dev.bistro.thm802 and can host any HTML page on the server. I consider Tom a victim whose we will send the link. The attacker can graft a simple HTML page, redirect HTML with the following code. So basically, this form send hidden redirect URI because it's a input type hidden. And submit a request to our authorization server. The measure the redirect page, then intercept authorization code from URI using the following code. Okay. Okay, the attacker can send Tom the link dev through a social engineering tactic or a CSRF attack. The victim and suspecting of the malicious intent click on the link, which takes them to a URI. So basically, you create. They give us all already there, so we can go to this. Remember what it means. This one is more. That's how we trick you can see now the legitimate before is bistro.thm. Now the attacker in our case you can control dev.bistro and this is domain is allowed. Let's make sure we're not creating any subdomain. The domain is allowed and the list of this, so it exists there. So let's say you do a phishing attack. You give this one to a user click, normally he will see it like this one, nothing dodgy about it. When you click log in, the user know this website like a Gmail or something, a victim, and you go to a victim 123, and if you say authorize, then of course the whole thing is stolen because this is not a legitimate redirect URI. So the attacker now was able to as I said, the attacker strategy is going to control over this. So when you control the domain, uh, it's easy to take over. What's the flag value after getting access token? From the attacker machine, they can utilize the intercept authorization code to call the callback endpoint and exchange it for a valid access token. In Outflow, as we saw earlier, the callback endpoint is always available, accepting the code parameter and return an access token. With this token, the attacker again authorizes access to the user protected resources. Okay, so because now we got, so I need to call the callback for flag, and we have a code. The code is here already, so what's going on? What's wrong with this now? Sometimes it. And the attacker can request the access token this way. Refresh token, and we got our flag for that thing. So mean here it means the attacker was able to control the subdomain. This is the first flaw. So this one is basically it's about have control of the subdomain. So let's move on now. More interesting stuff. This one is exploiting OAuth CSRF in OAuth. The state parameter is OAuth framework protect against cross-site request forgery attack, which occur when an attacker tricks a user into executing unwanted action on the web application where they are currently authenticated. In the context of OAuth, CSRF attack can lead to unauthorized access to sensitive resource by hijacking the OAuth flow. The state parameter helps mitigate this risk by maintaining the integrity of this state is like a random, if I'm mistaken, a random, or is this the new one? This is the new one. Authorization code flow for PKC. This is the latest OAuth, not the one I think we're playing with. Consider an auth implementation where the state parameter is missing or predictable. So in this case, like we checked in Wireshark before when it was empty, a static value like state or simple sequence number. An attacker can initiate an auth flow and provide a malicious redirect URI. After the user authenticates and authorizes the application, the authorization server redirects the authorization code to the attacker control URI. Now let's practice. Now we give us new application, import 8080, my contacts.try Okay, let's go there. I think this one is already installed here. My contacts.try like me. No, I hate you, Firefox. What's wrong with you? My contacts. So we have this up my contacts things. With credential attacker, once you log in, you will see a page that allows you to sync contacts to coffee shop app. Once the account are synced, all the current accounts from the client app are transferred to the coffee shop account. Okay, if you click on sync contact button, uh, First, visit website in the attack box. Okay, attack box. This is the attack box. And before we do that, we need to add that IP. Okay, sorry. My contacts dot TryHackMe. Okay, let's do that. So we have, this is the CSRF sync. Okay, this is the attacker part of it. First, visit the website in the attack box using the link with the credential attacker. Once you log in, you will see a page show that one. Once the account are synced, all current account from the client app are transferred to a coffee shop account. Okay, so let's test. If I go now to inspect network, if I click now, which one? This one? No, let's do it here in the attack box. Inspect. Let me cancel this. Factbook.try. Let's do this, and then we have attacker. No, not attacker. I forgot about it. So we don't have the state parameter. The authorization server won't have any way to determine whether the authorization could belong to attacker or victim, or whether the request is coming from attacker or the victim. Okay, now we I forgot this room. Why this one is said fact books? Let's first do the logout. I think there's okay, so let me go back also to this one. Okay, we'll go log out. So the one we go into is, we add that one, that's fine. So we have the app is this one in the attack box. And here we say we log in as attacker. Okay, let's leave it like that for now. This is the attacker system. Now to prepare the payload, the attacker must get his authorization code. This can be done by intercepting the authorization process using toolkit like Burp Suite or any other network interception tool. For the sake of this exercise, we have provided a link that allow you to get your authorization code without complaining the auth. The code of the flow pretty straightforward as shown below. Um, Next, copy link. So if you are the attacker, we can get the code. I'm trying to remember this. To get access token against the URL parameter in the response is the actor payload that we need to send to the victim. Copy the payload value which we'll use. What was the attacker password before? Attacker Tesla 123. So we got that code, which is this one. Okay, this one usually URL if in response to the actor payload that we need to send to the victim, copy the payload value which we will use while launching the attack. Once the attacker has obtained authorization code, he can prepare a CSRF payload. Suppose the attacker send an email to the victim with the link HTTP. After receiving the email, if the victim click on the link where access the attack authorization code, so let's go, this is the attacker machine, so let's copy, so we send this to the victim. The victim it should be somewhere here. What's the, to make sure the link uh, so this we send it to the client. The client will click on it and open it. And it's victim 123. What? Oh, victim. Let's go back again. Oh, that's one dead. Let's get another one. What? Why am not did the login log out a problem. Let me do private window. Invalid grant. I'm getting confused now. We need to get another one. Okay, we got a new one. Then we take this, send it by email to the client. The client will come open it here, and it's victim victim. The password is victim. What's going on here? V V I VISCTIM. Okay, now the password was correct. And here is automatic was synced. Account syncs successfully with attacker account. Two messages sent, and we got flag. And if I come here, did they give me anything? We have one email. What? Okay. So uh, to recap, the story here is we have this one is basically like the attacker must get authorized code. This can be done, but because now a CSRF, um, uh, because the application doesn't know who sent it, either the attacker and a user. So the attacker come first here. Remember, you get the code. Um, from the shop one, the coffee shop, and basically just send the link to the client, and client, because authorization is already done, it will sync automatically and force the user to um, uh, do something wasn't willing to do. Basically, that's why CSRF was in this room. I'm not sure how to explain it better, but I think I'm getting tired this Sunday and my brain is switching off. What parameter name does the client application include to authorize? See, it was states. There was no state value. So this one, what's sorry, exploiting CSRF. So there was a state is empty. So basically, we can just get authorization token and send it to the client, and that's the client, and force the client to just send us their contacts. Attacker perspective, first visit the website with quotation attacker. Once you log in, you will see this, and yeah, and we can confirm that if you do inspect network sync, and the sync will give us here login, client ID, response, but that one is empty. So yeah, uh, as I said, so the client ID, response type, redirect URI, and there is no state. So there is so let's put this vulnerability to attack the attacker third party account. So the state parameter was missing, so I think that's for now. The next one is what's the machine is still on. What symbol, no, what symbol, let's first read about it. uh, in the implicit grant flow, tokens are directly returned to the client via the browser without requiring intermediate authorization code. This flow is primarily used in single page application. Basically, you can see here when we did our stuff, usually the access token is not in the bar, but in this one's weaknesses. Exposing access token in URI, that's the whole point, problem is in URI. Inadequate validation redirect URI, no HTTPS implementation, proper handling of access token, log storage, session storage, and things like that. So, and that's why we have this new, what is that one? The new PKCE for auth 2 point grant type, and this one it go all these steps to authorization code and things like that to avoid this problem exactly for let's do the practice. Where exactly our practice? In the attached VM, go to Facebook factbook.thm8080. Okay, let's do before we do, remember we said make sure we are not logging in any way, so it doesn't okay, that's fine. So we go factbook.thm 8080. What was this one again? Sync status from coffee shop. Okay, you can see these there. Let's see what this app do. Okay, it asks me to log in. Victim victim one victim 123, and we come back. You can see the same response as before. It give me the client ID. The difference here is this. That's what the problem is. If you go this and copy it, and then if we go to here's what things we have: the client ID here, response type, and then we have redirect URI. What's the dangerous stuff here? We didn't finish. If I click authorize, we come here. No, but if you copy the bot at the top again now, look what we got. First of all, you got this hash, what do you call this one? Callback, and then you can see access token is there. Now we see that expire in token type beer and scope read and write. Oh, we saw scope before in Wireshark in when we tried to do that one. Sorry. So now here's the this is the where the problem of this exploiting implicit grant flow that usually for single page application. What we have, the access token, it's there in the bar. You can see where is it. So attacker can steal it. So now how to steal it? For example, if you have an application like that, in this room they will tell us exactly that it's yeah, this is simple code for the application, take status and publish or something, but they tell us for demonstrative purpose the status input feed is variable to XSS. We can confirm that. For example, if I say test, for example, now that's how it works, it published there. But if I say the classic, for example, script alert hi, um, if I press submit, of course nothing happening. To refresh the page, now it pop up, so we know it's an XSS. There is an XSS in the this, and that's you don't see it. Now what attacker can do to do these things? Usually when you have an XSS, you can send data to your server, so we can come back here, for example, and then um, We can run our server here, for example, Python 3.9 minus m http.server. It's running 8000, and then in the room they will tell us, for example, we can use this. uh, the goal is, let me copy this. Remember what is our goal here. uh, my server is 8000, so I'm using 8000 myself. So my attack box is 10.10. Attack is 2231 2231 2.231. Basically, this script, if you see Windows location hash, so basically he's starting this thing, wherever all of this, and then he's only looking for the first one, so he's interested in this one and ignoring the other one. Is splitting them, so basically we'll get this value. We want to steal this value, that's what is exactly. So if, for example, you put this access there and it uses a silent image, so if I put this, usually rooms like that, so if you submit there, of course nothing happened. Usually how they simulate it in CTF, you wait for a minute or two, and then there is a cron job that would read the page and basically refresh it. But in this room, you're not waiting. We can refresh the page. This is our test we did before. Now, if I go to there, we can see what I got. Steal token. Token equal this. You can see nj0t is what exactly we got here. That's what the token that script stole. You can see it's that. Or if you are usually in this thing, just steal the whole thing. To steal the whole thing, I can use this script, so we can steal the whole thing. Let's get that one. Uh, this one, it mean it just is trying to steal the only the first one. This one we can get steal everything. Doesn't matter. IP is 2231 8000 in my case. So for, because remember it uses also the same Windows location, but I don't need to just take the first one. I'm just taking the whole thing. So let's steal the whole thing. 2213. No, that's IP is wrong. 31. So if I submit now this, I should get the full URL, not just that key thing. Refresh. I should get two of them. Okay, so now I got the full one, the full URI, and also the script use encode. Usually when you do these things, better use base64 and encode. Can you just come here? I go to offline chef, and then we can say we got the whole code. So be this way, so it means we get the whole thing, not just access token. We can get everything one shot. So uh, so you can think about it. Usually when you have STF, you can just use this, get only just get the whole thing and finish. So this one you get the whole thing, the whole so basically we stole the whole code and the whole bar address, and that's what we got. We got the access token, we got expire, we got type, we got all of them, and that's exactly the what is this is doing here. And then the symbol, we know we've been talking about it, is that one. And then he said this one to validate the thingy key. Let's do that. Is validated this way. Flag validator. What exactly we validating is? We just validate, not you. I mean this one, the one we stole. And then we got our flag. Where's going you try hack me? Yeah, you want to play with me? You want to practice with us? Is there another lab? Other vulnerability and evolution of O 2.1 and service token expire. Access token with long or infinite lifetime pose significant security risk if an attacker obtains such token. Replay attacks involve capturing valid token and using them to gain unauthorized access. Attacker can exploit token multiple time. Okay. Insecure storage of tokens, storage access token and refresh token, and securely, example in local storage and encrypted files. Okay, evolution of O 2.1. The 2.1 represents the latest iteration of the evolution of the OAuth standard, building on the foundation of 2.0 to address its shortcoming and enhance security. Okay. Major changes. One of the most significant update is the deprecation of the implicit grant type, which was identified as the major security risk due to token exposure in your fragment. Instead, O2.1 recommend the authorization code flow with IKSC for public clients. So we're talking about this one. Additional, the O 2.1 is mandates using state parameters, so no, it's not option. So that's why we've been able to do these labs. So basically, all our labs now are dead if you switch to 2.1. Moreover, 2.1 enhance interoperability by providing clear guidance for redirect URI validation. Okay, build on auth 2.0 by addressing a security gap. This, if you want to read about it, or 2.1. Okay, and then which of the following has been removed? What? Is A, the implicit grant was removed. Uh, weak implementation of implicit grant flow and the redirect. So basically, yeah, this room is nice room to practice and redo sometimes. So to extend the flow, yeah, try to use, as I said, use Wireshark to give you more data. Use the browser. Sorry. Uh, See yeah, I was reading it this morning. I mean, we're talking about oath. This one. it was today, 12 September 2025. Cybercriminal group compromise sale, false instance for Delta theft and extortion. And strangely enough, uh, it's in oath, yeah, to show you like it's like was talking about. He said Salesforce allow organization to integrate with third-party application, often called connected app, using auth token for authentication after approved by an administrator or citizen privileged user. So this threat actor, ANC 6040 threat actor, have deceived victim into authorizing malicious connected app to their organization's Salesforce portal. So you can see how the oath, some of the labs we've been playing, they have certain things that they do in that. Uh, Hope guys you like it, and if you like it, please like and subscribe. If you have questions, let me know in the comment. I will do best my to answer them. I will try to do finish this one. I have couple of room I didn't do it, or I'm all up. I think I didn't do this. Yeah, thank you very much, and yeah, have a good day.